good day to the fellow judges, teachers and friends. Today, my team from SMK Kota Kemuning is going to explain the project that we did called the Automated Aerophonics. 1 in 9 people around the world are undernourished. The vast majority of the world's hunger live in developing countries. Based on the statistic that I've gotten, since the 1900s, some 75% of crop diversity has been lost from farmer fields. Better use of agricultural biodiversity by controlling the environment of the surrounding for the growth of plants can contribute to more nutritious diets, enhance livelihoods for farming communities and more resilient and sustainable farming systems. Based on these statistics, we have made an automatic aeroponics plant growing system that is not affected by drastic climate change and severe weather, but uses the surrounding environment readings such as daylight sensor, temperature and humidity to control the growth chambers environment.
Crisis proved to be one of the most prevalent and disastrous issues currently affecting citizens of many countries in the world. About 1 in 9 of people are going through hunger and doesn't lead to a healthy life. This is mainly caused by 2 issues. Firstly, the overpopulation and also the lack of food. So let's say we can make a farm that's almost completely self-sustainable like this one. A farm completely acting with a minimum to non-human interaction. The farm provides a vast potential growth for our world. As the automation and technology continue to extend, why should agriculture be integrated? This project is unique because it can save 98% lesser water than the other growing methods. No growing medium is involved and the roots are exposed to many oxygen.
Our objective is to grow food in a controlled and efficient manner in order to provide food for all while protecting the environment.
So the way we made the project is first we put the generator inside this reservoir and we made 2 little net pots so we can put the plants in and the generator will push out water into each of the plants, and this is the grow light, so in case if it gets dark this light will turn on and it will still provide nutrients to the plants. And this is the diagram for it and it's powered by a laptop and also a power supply.
Now I'm going to explain about the concept and implementation. So the concept of this original project is actually the plants that is suspended to the air and the air has a good moisture and also high level of oxygen. So the plants, it has to be depend on very little support so that the plants can at least be more stable. Comparing to the hydroponics and aeroponics, aeroponics use less water because the plants are actually sprayed to the roots of the plant. Compared to hydroponics, they are actually immersed in the water. So this will actually use a lot of water, but compared using the aeroponics, they use less.
Continue.
Now looking at the engineering and the stability of the structure, we use this container the rollers, where in the real time we can use something, a bigger container with a bigger rollers. So this will be like easy for us to move through the models. And and the growth chamber is actually small, size of a net pot. So it really can be suitable for small type of plants or like the most suitable plant will be like cabbage, spinach or coriander. Those are the examples. And done.
Great.
Okay, looking at the programming and the concept flow chart, in front of me is the Arduino, which is a brain of this project. So Arduino controls the relay and controls the motor of the light and the pump. So the sensors, they are fixed 2 sensors which are humidity sensor and light sensor. So when light sensor detects the intensity of the light, so when the intensity of the light decreases, it lights up. Whereas when it's high, it doesn't light up. And looking at the humidity sensor, when the temperature increases, the pump will activate. But if the temperature decreases, the pump will deactivate. So this will allow the plants to grow in a good environment.